Hello viewers, in today's class we are going to discuss an important problem from definite integrals involving greatest integer function, right? So here we have the problem that is integral from 1 to e square, and the integrand is greatest integer of log x, right? So here we see that inside this greatest integer function symbol we have another greatest integer function, right? And here e is the exponential number, and this log x is to the base e, right? So it implies that here we are dealing with the natural log, right? So let us start, and let us first call this integral as I, right? So here we'll adopt the method of substitution to solve this problem, right? So let us take t is equal to log of x, or we can take the base e here, right? So we'll assume t is equal to log of x. So now x is equal to e raised to t, and if we differentiate both sides with respect to t, we get dx over dt is equal to e raised to t, and dx is equal to e raised to t dt, right? So we have got this value of dx here, and now see here the limits of integration are from 1 to e square, that is the lower limit is 1, the upper limit is e square. So when x is equal to 1, then the value of t is the log of e1. Here we'll take x is equal to 1, so log of 1 is obviously 0, and when x is equal to e square, then t is equal to log of e square to the base e, right? So we can write this term as 2 times log of e to the base e, and log e is 1, so we have 2 times 1 is equal to 2, right? So log of e to the base e is 1, right? So we see that when x varies from 1 to e square, t varies from 0 to 2, right? So now let us rewrite our integral I in terms of t. So we can now write 0 to 2, and we have greatest integer of log x, right? So we can replace log x by t, so we have here greatest integer of t, and for dx we can write e raised to t and dt, right? So now here we observe that t varies from 0 to 2, right? So here we have 0, and here we have 2, and between 0 and 2 we have the integer 1, right? So what we will do in the next step, we'll break this integral as a sum of two integrals, that is the first one is from 0 to 1, and the second one is from 1 to 2, right? So now we can write 0 to 1, and we have greatest integer of t here, and e raised to t dt plus, and the second integral is from 1 to 2, because whenever we come across with the greatest integer function, we always search for the integers, right? So 0 to 2 is the limit, and between 0 to 2 we have the integer 1, so we'll split this integral as a sum of two integrals, and the breaking point is x is equal to 1, right? So 1 to 2, and here we have greatest integer of t, and here we have e raised to t dt, right? So now let us analyze these two integrals one by one, right? So let us first take this integral, and see here t varies from 0 to 1, right? And when t lies between 0 and 1, then as per the definition of greatest integer function, the value of greatest integer of t must be equal to 0, right? So the value of now this term is greatest integer of t should be equal to, here we'll take for this term we'll take 0, so we have greatest integer of 0, and the value of greatest integer of 0 is 0, right? And similarly here, t lies between 1 and 2, so we have greatest integer of t is equal to 1, right? So the value of this entire term is greatest integer of t is greatest integer of 1, that is equal to 1, right? So now we can write here 0 to 1, and the value of this term is 0 here, so we have 0 e raised to t dt, and here we have 1 to 2. The value of this term is now 1, so we have 1 times e raised to t dt, right? And this integral is 0, and here we have the integrand e raised to t. The integral of e to t is e to t, and the limits are from 1 to 2, right? So now we can simply substitute the limits here. So we have e square minus e raised to 1, and we can write e common, so we have e minus 1, right? So viewers, the value of this integral is given by e square minus e, or e times e minus 1, right? So this is how we can simply solve these type of problems.